All right, we're still on 6.1. 6.1. Okay, so now we're going to look at this curve. This is from your book. It's like a candy, right, with a wrapper around it. So we have two curves. The green one is g of x, and the blue one is f of x. If we want to figure out the area between the curve from A to B, we're going to have some problems. Because if we integrate straight through, the question is which curve is on top. From A to this point here, f of x is on top and g is on the bottom. From this point, let's call this 1 and 2. From 1 to 2, you can see that g is on the top and f is on the bottom. And then from 2 to b, you can see that f is on the top and then g is on the bottom. So then, because the curve switches back and forth, we can't just integrate straight because the curve, we don't know which one to subtract which one. The top curve keeps changing. So what we have to do is change how we integrate. We have to figure out where the two curves intersect and switch positions so then we can integrate it correctly. So for example, this one, you would have to do from A to 0.1 of f minus g plus from 1 to 2 of g minus f, and then from 2 to b of f minus g. So this is going to switch for you, and then you have to integrate each area by itself. So when you have no idea how this graph is going to look like, then it's going to be really tricky for you to figure out, do they intersect, do they switch over? So we're going to have to look at some techniques to do that. Okay, are you guys okay? Copy down everything. This is also in your book, so if you didn't get to copy it down, you can look at the book. Okay, let's look at this example. Find the area of the region bounded by the graphs of y equals sine x, y equals cosine x equals 0, and x equals pi over 2. Okay, we're going to do this algebraically and using the calculator. And this, they already give you a graph, so it's easy to figure out. Okay, so you can see that the red graph is cosine, the blue graph is sine. At pi over 4, it's going to switch position. Okay, can you write an integral expression for how you're going to figure out the area between the two curves? Okay, go ahead and try that. Okay, so for those of you in the back, you may not see this very well. Okay, so this point is pi over 4. So you're going to integrate from 0 to pi over 4 with cosine minus sine. And then from pi over 4 to pi over 2, it's going to be sine minus cosine. Okay, so let's write that down. From 0 to pi over 4, it's going to be cosine x minus sine x dx. And then from pi over 4 to pi over 2, it's going to be sine minus cosine dx. Okay, so go ahead and figure out the answer algebraically. So using just your written skills, figure out what the answer is. Don't use calculator. How are you guys? Finished? Okay, the answer is -2 plus 2 root 2. Yes? No? Okay, give me a thumbs up if you got it. Give me a thumbs down if you didn't get it.
Why is it -2?
Why is it -2? Okay, let's go ahead and integrate. 0 to pi over 4 of cosine x minus sine x dx plus pi over 4 to pi over 2 sine x minus cosine x dx. Okay, so integral of cosine is sine. Integral of minus sine is just cosine. Okay, from 0 to pi over 4. Plus Integral of negative sign is negative cosine, negative cosine. Integral of negative cosine is negative sine from pi over 4 to pi over 2. Okay, evaluate. Sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0 plus minus cosine of pi over 4 minus sine of pi over 2. Got this wrong. Pi over 2 minus sine of pi over 2. No, from the top to bottom. Minus cosine of pi over 4 minus sine of pi over 4. Okay. Sine of pi over 4 is square root 2 over 2 plus square root 2 over 2. Sine 0 is 0. Cosine 0 is 1. Plus cosine pi over 2 is 0. Sine pi over 2 is 1, so that's a negative 1. Minus cosine pi over 2 is square root 2 over 2. There's a negative in the front, and then minus square root 2 over 2. Okay, simplify. Square root 2 minus 2 minus 2. So 2 root 2 minus 2. Okay, now use our calculator. Okay, so the same thing I showed you yesterday. So what you want to do is first type in both curves in the y equals 2. That way you can just recall it later and you don't have to type it in again. But you should triple check that your your typing is correct. This one is easy because just sine and cosine, but when the next question is going to be really complicated, make sure you type it in once and that one time is all correct. And you probably want to just write it on the side. y1 is equal to y2 is equal to, that way you can reference it later. I'm going to make y1 sine x and y2 cosine x. And then what you want to do is just type it in as is. So you're going to evaluate that part on its own and then this part on its own. Make sure you're in radian, okay? Okay, try it with your calculator. If you don't know how to recall y1 and y2, let me know if you're on TI 84, and then I will show you. All right. According to the calculator, your answer should be 0.828. Okay, make sure you have 3 decimal spaces, okay? All right, let's try another one. Find the area of the region bounded by y equals x and y equals x cubed. Okay, this time no graph. You're not going to use your calculator to figure out how this looks like. You're going to draw based on what you think. Remember, parent functions. 2 curves, x and x cubed. Draw x and x cubed. Try to figure out where they intersect. So you're not going to use your calculator this time because I want you to see if you can actually draw this and figure out where they intersect. All right, y equals x. Easy. What about y equals x cubed? How does that look like? Like this, right? Okay, so that is going to look like this. So where do they intersect? Well, 1 and negative 1, and they switch direction, right? Okay, so at negative 1, this curve is going to have, oh, that's too big. This curve is going to have y cubed on the top. X cubed on the top. And then once it goes to this side, from 0 to 1, x is on the top. Okay, so you're going to have to split it into 2 regions and integrate. So go ahead and do that. Another thing you want to look at is symmetry, right? This is a symmetrical graph. So basically, you can just find one of the area and double it. So it will save you some time. So when there is an apparent symmetry where it is exactly the same thing repeated, you could use that to help you so you don't have to do, two integrals. Okay, the answer is 1/2. Okay, so each area is 1/4. So we add them up, it's 1/2. All right, okay, let's try another one. Are you guys good? Okay, this one, you definitely have to use the calculator. That is crazy. For those of you who cannot see what this looks like in the back, y equals x over square root x squared plus 1. Please don't integrate with your hand. When it says use calculator, use calculator. I know your use sub skills are superb, but don't use the do it by hand if you don't have to. Okay, first graph both. So maybe make this y1, make this y2. And yesterday I showed you how to write fractions on your calculator. That way you don't have to go through a lot of parentheses. If you want me to show you the fraction button again, I can. Okay, so graph those two. There are 2 points where they intersect and it does switch over. So you're going to, actually, no, this one doesn't switch over. This one is just one big graph intersecting at 2 points. One is on top of the other and it's very clear. And all you have to do is just integrate, but the calculator practice. If you're stuck, let me know. Okay, so the area is equal to 0.785. Okay? Yes. Okay. Next one. Should we do this one? Let me double check if there's a, oh, this one's much better. I like this one. Okay, let me write it out for people in the back. y1 is equal to cosine x. y2 is x plus 2 sine to the 4th x. You have to figure out how to type in sine to the 4th on your calculator, okay? So I showed you that before. But if you forget, let me know. They do switch somewhere in the middle. So you have to figure out where that is on your calculator, with your calculator, and then you have to write 2 integrals and integrate. The 4th, so what you want to do is just type sine x, it's going to look like this, another parentheses, and then put 4th. Okay, so use your calculator. They do intersect in 3 places, and they will switch, swap directions. Okay, I'm going to give you the integral part, so you can double check to see if your limits are correct. Negative 1.912, always 3 decimal digits, negative 1.224 of x plus 2 sine to the 4th x minus cosine x dx plus integral from negative 1.224 to 0.608 of cosine x minus x plus 2 sine to the 4th x dx. Okay, the answer is 1.704. Okay, make sure you have 3 decimal digits. You can't have more than 3. Yeah, you can have more than 3. It just has to be at least 3. Okay, that's it for today.